Here we go. This is Mr. Bing, and it is Tuesday, October 13th at 10:09 a.m. It is second block at Liberty High School, and we are in Project Lead the Way Engineering Course 1, which is the Introduction to Engineering Design. And the assignment that I want to go over today is 1.2.4, which is dimensioning. What's it called? Dimensioning what? Something in dimensioning. We'll figure out what it is. And so I'm going to share my screen a couple of times. And look, fundamentals, Tanner. Fundamentals of dimensioning is what the assignment is called. Let me bounce back to Schoology real quick, just to give you just a quick reminder that in the last couple of weeks we've been doing 1, 2, 2, and then 1, 2, 3, and then 1, 2, 4, and then we will be doing 1, 2, 5. And so the announcements. Oh, by the way, you should be looking at this every day. Tuesday, October 13th. What's late? Make sure you turn that in if you haven't. Today and tomorrow we're doing 1, 2, 4. The end of the week, we're doing 1, 2, 5. It will be due the following weekend, not this weekend. 1, 2, 4 is due this weekend. Check for missing scores. Make sure you have fixed anything that is wrong. If you have a blank score and you don't fix it, it will become a 0 eventually. Okay, back to the assignment. 1, 2, 4, fundamentals of dimensioning. I'm going to do sort of a speed run. And so what I've learned is that my videos go on and on and on and on. So I'm going to try to do it super fast. And then you, because you're teenage Americans, you know to pause and rewind and watch it again and do whatever you need to do to figure out what it is I'm talking about. 1.2.4 fundamentals of dimensioning. Yes, you have to do a notebook entry, of course. Make sure on your notebook entry that you have a table of contents entry for today's date, 1, 2, 4 fundamentals of dimensioning. And then for me, I'm on page 29, 30, 31, and 32 in my engineering notebook. Okay, yes, you got to write down the goals. Yeah, no materials for this. We're not actually doing the structure cards from the previous assignment. We never did that in our previous assignment. Dimensioning examples. You should look at this. You don't need to take notes. Let me say hello again. You don't have to take notes on that, but I would like you to look at this because it gives you an idea of where we're going. Here's parts, 3D view, and their multi-view with dimensions. This is what you will end up with as your final product. And as a matter of fact, these 3 objects you may choose, if you'd like, you may choose to use as the 1 or 2 or 3 of the 4 objects that you have to make in this assignment. Hello again. And back to here. And let me see. So the dimensioning examples, look at that. You don't have to take notes. Isometric and orthographic graph paper. That's Sam just walked by. Hey, Sam. Isometric and orthographic graph paper, that's just a print if you need it. And dimensioning flowchart, it actually appears lower in the assignment for you to look at. I don't know if it's necessary. I can't even find it. I don't know if it's necessary to take notes on that. So the resource is not really any note taking. Yes, look at all of them. When you do your notebook entry, of course, you have to do a note for each paragraph. And look, these are like some easy little cheat notes that you can just take that. I certainly would not write word for word what's there, but I would try to abbreviate it in a way that makes sense. So a note for each paragraph. Step 1 says form groups. Don't worry about that. Step 2 says as a team. Don't worry about that. But then what I do want you to do is in your notebook with pen on paper, I want you to draw this multi-view. Isometric, 3D isometric, and then the orthographic top, front, and side. And then I want you to draw this and dimension it as shown. These are all the names of the different dimension lines. You can look at them. You know, it's pretty obvious what they are. Extension extends, dimension shows the dimension, etc. Look at that. Make this on pen and paper, and then later in the assignment, I want you to make it again with your 3D modeling, Autodesk Fusion. And then I think that's the same object. Is that the same? Yeah, it's the same. You don't have to do that again. And this is that flow chart that I was looking at. Look at it. Don't take notes on it. The rules. I got to tell you the rules of dimensioning. That's what I taught them just now with actual teaching. So there are rules about dimensioning, and there are rules about dimensioning. And one of the rules is that you should, and by the way, you can break the rules when necessary, but you try to follow them. One of the rules is that the dimensions have to be in between the views, not out here, in between the views, if you can. There should also be an overall dimension, which is the outermost dimension, and you can see that here. And then a dimension an inside dimension for every feature that needs to be detailed in the assignment. And you notice that there's a 3 here and there's a 1.5 here, but there's nothing here. And that's because they expect you to know that 3 minus 1.5 is 1.5. They don't want you to show that dimension if it is simple arithmetic to figure out what it was. The reason is that they don't want a lot of clutter in a multi-view. Someone has to read this multi-view and perhaps build it. They don't want to see all kinds of information that they could just figure out for themselves. So you do not need to show a missing dimension if arithmetic allows you to find it easily. Make sure your dimensions are in between the views. And then also, you notice there's an overall 3 inches here, and it is also overall 3 inches here, but it's not shown because it wouldn't need to be. You just know it's 3, you know it's 3. You never double dimensions or repeat dimensions or redundant dimensions. That's not necessary. You try not to do that. And so you got an overall and one of the features, you got an overall and one of the features. Here you have, that's a diameter of 1/4 inch. And that leads you, the leader leads you to the feature, which is this circular piece. It's actually a hole that goes through. And this diameter 1/4 inch follows a leader line, which is diagonal. So it sort of visually distinguishes itself from the rest of the multi-view of the part. And then obviously a dimension right here. Ooh, and look at this. I forgot, dudes, to tell you that there's actually 2 errors in the example. There's another one, I'm not going to show you at this moment, but there's another one that's outside of the view. I never noticed that. So, but that's an example of sometimes you break the rule when you have to. This dimension you would try not to put on the outside. You want to be on the inside of the views. However, you break the rule sometimes. Another rule that's broken here is that this dimension line and this dimension line cross. You should not do that unless you have to. And the designer of this chose to do that because he or she felt like there was no other simpler way to do it. So sometimes you break the rules. Overall dimension here, this 1 inch turns out to be the same dimension as this 1 inch. And these transfer just like these dimensions transfer and these dimensions transfer, these dimensions transfer kind of in a sweeping it around. Also, I did not mention that there are dash lines here, which are hidden lines. There's a alternating small and long dash, which is a center line, shows the feature that you cannot see that's running through the interior of the object, and then also shows the center of that object. And we know from the 3D isometric that it does appear to be a hole that runs through the entire thing. Speaking of isometric, 3D isometric, there's no dimensions shown. You shouldn't be. That's like a rule. Sometimes you break it. There's a rule, no isometric, no dimensions in the isometric, and then also no hidden lines in the isometric. That's why you only see hidden lines in the top, front, and or side. That same circular feature with the hidden lines here is also shown here from a different view, and they have labeled it for you so you can see what that is. And then the dark lines are the object line itself, the visible features. So let me see if I got all that. You got the dimensions are in between if possible. You get an overall in the outermost. You have the interior features shown underneath. You don't include any dimensions that can be easily figured out mathematically, and there's no redundant dimensions. You try not to cross dimension lines. You try not to put dimensions outside of the view. And you try to focus most of your dimensioning in the front view and avoid the other views if you can, which clearly they were able to here and they were not able to here. So speed run. Remember, I said speed run. So let me close that. So make that object. That object, it looks like the same. It is the same object. Don't do that twice. This object looks like the same, but it is a little bit different. Feel free to do this one, pen on paper in the multi-view, dimension it. Do it also in Fusion 360, dimension it. When you do a dimension, we already talked about this. The multi-view is called a drawing, right? It's called a drawing file. And so follow the Fusion 360 instructions that are on their website, or Google, or just fiddle around with it and figure it out yourself. That's what I usually do. Here's a video you can watch for 19 seconds. And there's an object if you choose to do that one. And then there are conclusion questions. Yes, answer the conclusion questions. Don't worry about going beyond. And overall, you need to have 4 pen on paper sketches that are fully multi-view and fully dimensioned. You need to have the same or different 4 objects in Autodesk Fusion 360, also multi-view and fully dimensioned. And so there's a lot of work here, probably more work than I've given you time for, but I like for you to feel a little bit overwhelmed. That's okay. Something else I forgot to tell you is that this 3 and this 1.5 and that half and that 1.5 and all those others, those are inches. Inches is the standard unit in engineering. Inches or feet, depending. And so that's why you don't see units. Again, they don't want clutter on these drawings. They just want to give you the information as quickly and efficiently as possible without a lot of mess. People have to read these drawings and figure out what they mean. Okay, I think that's it. Engineering notebook, the assignment 1.2.4. If you're still working on 1.2.3, yes, do that and master it before you even do this assignment. And check out the instructions, see if we can get this done this week and move on. And Schoology every day. I'm running a conference actually right now, which you at home should look at literally during class, because you get to see what is on our screen, which is what's on our screen right there in front of the class. That's it. That's on our screen. So look at that. Let me stop the share and say goodbye to you like in person. This was actually pretty good. Really, really fast. Watch it again. Watch it twice. Well, that would be again. Watch it 3 times.